Welcome to page 5. Here we're going to start with a voltaic cell. We know it's a voltaic cell because we have the voltmeter and the salt bridge. Now, the first question asks, in which half cell will oxidation occur? In order to figure out that, we need our reference table. Let's pull up reference table J. Now, what we want to do is we want to compare the relative activity of lead found here with zinc. Now, you notice that zinc is more active than lead according to reference table J. These are both metals, and all metals desire to lose their electrons to obtain stable noble gas electron configurations. So we see that zinc is the better loser of electrons, while lead will be the gainer of electrons. We can always imagine that in a spontaneous chemical reactions, the electrons fall down. So here, we'll notice that oxidation is the loss of electrons. So the half cell 2 is where the zinc is located, where we can have the loss of electrons. The next question asks us to write the balanced half reaction for the equation that happens in half cell 1. So here in half cell 1, we see we have lead. And going back to reference table J, we see that lead is going to gain electrons. Now, make sure that you go and look at your diagram to get some clues. So here, we'll notice that we have lead on the reactant side, and we have lead on the product side. So we simply have to go and write our half reaction. So here, we're going to write that we begin with lead ions, and we're going to end with lead atoms. Now, this equation is not balanced because 2 does not equal 0. So in order to balance the equation, we have to add in the electrons. The number of electrons to be added must equal the difference between the two oxidation states. We need 2 electrons, and we'll add them to the more positive side, or the reactant side. So here, lead is gaining electrons, as we can see they're on the reactant side. And its oxidation number is reduced. It goes from 2 to 0. The next question asks us to describe the direction of electron flow. Again, we refer to reference table J, and we see the electrons go from zinc to lead. So in this case, electrons are going from the right to the left, or you can simply say from the zinc electrode to the lead electrode. The next question is a simple definition question, and it asks us what type of energy transformation happens in an electrolytic cell. Recall that electrolytic cells require batteries, so they're non-spontaneous chemical reactions. So that means that we change electrical energy into chemical energy. The battery provides the electrical energy that forces the chemical reaction to occur. The next question has us referring to this electrochemical cell. We see it's an electrolytic cell because it has a battery. Now, it asks reduction occurs at the, and we can remember the saying, red cat. So reduction always occurs at the cathode. Now, how do we figure out which electrode is the cathode? Well, this cell requires a battery. And the purpose of the battery is to provide electrons. Recall that electrons have a negative charge, so electrons will originate from the negative end of the battery. The electrons will travel through the wire, and in this case, they'll travel to the key. So we see that the key is going to be gaining electrons or undergoing reduction. So the key is going to be the cathode. So again, we see that because the gain of electrons is reduction, and we remember red cat. That makes choice 2 the best answer. In the next question, we're referring to this voltaic cell. Notice they tell us it's a voltaic cell, but we also observe the salt bridge, 2 separate containers, and a voltmeter. Now here, they ask us, in which half cell does oxidation occur? Now we can figure this out 2 ways. The first way we can figure this out is simply by looking at the chemical equation they provided us. So here we see that we start with a silver ion and a lead atom. The lead is by itself and no oxidation state is given, so it must be 0. And then we form a lead ion and a silver atom. Since the silver is by itself and no oxidation state is given, it must be 0. So here we notice that the silver's oxidation state is going from 1 to 0. That is a reduction. So that means that the lead is going to go from 0 to 2. That is an oxidation. So lead is undergoing oxidation. So we look for which half cell lead is located in. And we can find lead here on the left. That's half cell 1. Now the other way to figure out which half cell oxidation is occurring in is by using our reference table J. Here we're dealing with both lead and silver. We notice that lead is a better loser of electrons than silver. So lead is giving its electrons to silver. The loss of electrons is oxidation, and the gain of electrons is reduction. So again, we can observe that oxidation happens in half cell 1. Now, based on the fact that lead is giving its electrons to silver, we see that the electrons are flowing in the left to right direction. Finally, we're asked to write the half reaction referring back to our original equation for what's occurring in half cell 1. So we already did the work of assigning oxidation numbers, and we see that half cell 1 contains the lead. So we're going to write the half reaction for lead, which goes from oxidation state of 0 to 2. That's oxidation. So all we simply need to do is write the symbol separated by arrows. Referring back to the equation, we're going to put in oxidation states. And now to balance this, we're going to have to add electrons. Remember that oxidation is a loss of electrons. Things we lose in chemical reactions are always written on the product sides, and we always have to make sure that the mathematical expression for the charges is true. So I'm going to add 2 electrons to the product side. I'm going to verify that this is true because 0 equals positive 2 plus negative 2.